When we are looking at equations in two variables, normally we are talking about lines. So we're looking at linear equations in two variables in one of two forms. First is standard form, which is ax plus by equals c. And the second form would be slope-intercept, where y equals mx plus b. Slope, you probably remember in slope-intercept form, is the m value. In standard form, it is the opposite of a over b. And I do want to write a couple fun facts about each of these that I do want you to remember. First of all, a has to be a positive number in standard form. So at some point you have to multiply potentially to make a positive, but a has to be a positive number. A, B, and C all have to be integers. If you remember sets of numbers, that means they cannot be fractions. For slope-intercept form, I wanted to add two fun facts here. B is your y-intercept, and it is written as a coordinate 0 for x, b value for y. Also, to find slope, you have an equation given two coordinates, which we are going to use later in this section. So you can find slope by doing the change in y over the change in x. Now there are some special case lines, which are horizontal and vertical lines. Horizontal lines are written in terms of y. They only have a y-intercept and a slope of 0. Because if you think about a horizontal line, you can walk down that line. So a horizontal line has a slope of 0, written in terms of y. Vertical lines are written in terms of x. They have an x-intercept, and they have an undefined slope. Vertical lines would go this way. There is no way to walk that line, which is one of the reasons it has an undefined slope. Usually you'll see slopes here like a rise of, let's say, 1, but then a run, because remember slope is rise over run, of 0. And 1 divided by 0 is why we are looking at an undefined slope. So in this box here, I have all three situations. This first one is standard form. The second one is slope-intercept. And the third one is either a vertical, in this case, it's a horizontal line. Now for each of these, there's going to be nice things to find and annoying things to find. Let's start with this one down here because it's probably the one you're most familiar with. That one for slope, it appears right in the equation. The y-intercept, again, appears right in the equation. The x-intercept is a little more work because to find the x-intercept, we need to plug in 0 for y and then solve for x. That's going to give us our x-intercept. In this case, it gives us -3/2, 0. Now for standard form, the x-intercept, when we plug in 0 for y, this second term is going to cancel, which leaves us with a very simple equation to solve. Our x value here would be 4 when y is 0. The y-intercept is just as simple. You are plugging in 0 for x this time and solving for y. So this term would cancel. Simple division gives us a y value of -3. And you can do that in your head. Slope for this one is a little more challenging because it's the opposite of A over B. So in this case, it is the opposite of 3 over B, which is -4. This simplifies down to 3 over 4. Horizontal lines, we need to go back for that fun fact. Horizontal lines go this way, so they have a slope of 0, a y-intercept, in this case at 3, and no x-intercept. That line would only go through the y-axis. All right, so let's look at graphing, and we're going to use that information from the box to help us graph this. When you're given standard form, you are looking to graph using the intercepts. It is the quickest way to graph. So you're plugging in 0 for x and solving. So if we plug in 0 for x, this term would cancel, and we would get a y value of -2. Then we're going to do exactly the opposite, where we are plugging in 0 for y and solving for x, in this case -3. Then all that's left is to plot and connect. Plot our two intercepts and use some sort of straight edge, please, so that your freehand does not look like mine, and graph. This next one has slope-intercept form, so we are going to start with the y-intercept, 0, -3, and then we're going to use our slope, up 1 over 2. Remember, it's rise over run. So all we need is 2 points to define a line, but you can draw more if it makes you happy. 2 more lines to graph down the bottom here. The first one is an x equals line at x equals 4. That is a vertical line over here at 4 on the x-axis. So we can drop a vertical line down at 4. This second one, when you isolate y, you get a y value of 2. This one is a horizontal line in terms of y.